This is CPM Precalculus Chapter 2, number 171. So here we're asked to solve the triangle to the right, triangle MNO. Okay, so before I go ahead and solve this, what I want to do is make sure it's labeled. M and N and O are the vertices. Across from angle M is side M. Across from angle O is side O. And across from angle N is side little n. Right? These are all little n's as the side. Solving the triangle is just going to produce 6 different values: angle M, angle N, angle O, and also side M, side N, and side O, right? I'm going to fill in what's given. We're given O is 50 degrees, angle O. Angle N is 63 degrees. And side M is 7 units. Okay? So this is going to be our answer box. Okay, the rest of the work we're going to do below. All right, so the first thing I notice when we have a triangle, if we have 2 of 3 angles, the third angle is the easiest thing to find next, right? Because angle M we can find by just knowing that we add 3 angles in our triangle. What is the sum? That sum is always 180 degrees. So replace angle O with 50 degrees, angle N with 63 degrees, angle M 180 degrees. Now we can use this information to solve for angle M, right? Combine 50 and 63, that's 113 degrees, plus angle M is equal to 180 degrees. Subtract 113 from both sides. Angle M is equal to 67 degrees. Okay, so let's go ahead and put it in our answer box. Right, and let's continue. All right, so continuing on, I'm going to even write it here in our chart, 67 degrees. So now what do? This is not a right triangle. We have the law of cosines and the law of sines in our tool belt. So what I'm going to use is the law of sines, because I see we have angle M and side M, right? So I can use that to find, for example, side O and side N. And these are all acute angles, so I don't have to worry about any ambiguous answers when we're looking at obtuse angles. So sine of M over side M, okay, let's find side O, is equal to sine of angle O over side O. Okay, it looks confusing, but this is not 0. This is just capital O and lowercase letter O. All right, so we're solving for O, so I want to get it in the numerator, so I'm going to multiply both sides by O. These cancel out. So I get O times sine of M over M is equal to sine of O. I want to multiply both sides by side M, so these cancel out. O times sine of M is equal to sine of O times M. Divide both sides by sine of angle M. This is big M, and I get little o is equal to sine of angle O times little m divided by sine of angle M. Okay? Now I can just plug in what we know. Angle O we know is 50 degrees. So sine of 50 degrees times side M is 7 units divided by sine angle M is 67 degrees. Okay? So let's go ahead and bring out our calculator. Turn it on. Make sure I'm going to clear it and make sure I'm in radians. No, degrees mode, yes, because we have angles with degrees. Now let's go ahead and compute that. Sine of 50 degrees times 7 divided by sine of 67 degrees. And that gives us side O is approximately 5.825 units, right? I put all those digits, so I could round at 8.2 to make that at 8.3, but I'm going to go with 5.825. Okay, putting away the calculator, putting this answer in my answer box, 5.825 units, making this approximate so I know if I'm ever checking that it's not exact. And finally, I want to find side N. So side N, right? I'm going to use the same property, the law of sines, to know sine of angle M over M is equal to sine of angle N over little n, right? Solving for little n, I'm going to solve it the same way I solved for little o. Multiply both sides by n, right? They cancel here, and I get n times sine of M over M is equal to sine of N. I'm going to do two steps now. I'm going to multiply both sides by M over sine of M. Multiply by M over sine of M. This is going to cancel sine of capital M and lowercase m over here. I'm going to N on the left is equal to sine of N times M over sine of angle M. Okay? A lot of M's and N's. Angle N is 63 degrees. Side M is 7 units. Angle M is 67 degrees. Okay, so now I plug these in my calculator. Sine is 63 times 7 divided by sine is 67, and I get 6.77, and that 5 rounds up because it's next to a 6. Okay? Let's get rid of the calculator. 6.776, put it here. And again, this is approximately 6.776 units. Just like I should have written down here, this is approximately. Right? And so there we go. We solved triangle MNO. We have all three angles, all three sides. And that ends for us CPM Precalculus Chapter 2, number 171.